Hey there, universe nerds. Imagine throwing a stone into a pond and watching ripples spread across the surface. Now, instead of water, imagine space-time itself rippling. That's not just imagination, it's real. These ripples are called gravitational waves, predicted by Einstein over a century ago and finally detected in 2015. They are the faint echoes of the most violent events in the cosmos, and they've opened an entirely new way of exploring the universe. So what exactly are gravitational waves? According to Einstein's theory of general relativity, massive objects warp the fabric of space and time. When those objects accelerate, like two black holes spiraling into each other, they create ripples that spread outward at the speed of light. These waves literally stretch and squeeze space itself. Every time a gravitational wave passes through you, your body changes size ever so slightly, smaller than the width of a proton. You don't notice it, but sensitive instruments can. The first detection came from the LIGO Observatory in the United States in September 2015. Two laser beams fired down 4-kilometer-long tunnels were used to measure distances with unimaginable precision. When a gravitational wave passed through, it stretched one arm of the detector and squeezed the other, changing the distance by less than 1,000th of a proton. Yet the signal was clear. Two black holes had collided over 1 billion light-years away, and Earth felt the ripple. That moment changed astronomy forever. Before, we could only study the universe with light, visible, radio, X-ray, infrared. But gravitational waves don't care about dust, gas, or darkness. They travel through everything, carrying information about events we could never see with telescopes. It's like suddenly gaining a new sense, hearing the universe instead of just seeing it. Since then, detectors like LIGO in the US, Virgo in Italy, and Kagra in Japan have recorded dozens of gravitational wave events. Most come from black hole mergers, but in 2017, a neutron star collision was detected. That event was groundbreaking. Telescopes saw the light and detectors heard the waves, giving us a complete picture of one of the most spectacular explosions ever witnessed. It confirmed that neutron star collisions forge gold and platinum, proving what astronomers had suspected for years. The sound of gravitational waves is eerie. Scientists convert the signals into audio, and what we hear is a short chirp, a rising tone as the objects spiral closer, then a sudden stop at the collision. Each chirp is unique, like a cosmic fingerprint. From the details of the signal, astronomers can measure the masses of the objects, their distance, and even how fast they were spinning. Gravitational waves are whispers of the universe's secrets, waiting to be decoded. And we're only getting started. Future detectors like the Einstein telescope in Europe and LISA, a space-based observatory, will be able to hear even fainter waves from the mergers of supermassive black holes at the centers of galaxies. They might even detect ripples from the Big Bang itself, carrying information from the universe's first moments. Gravitational waves could unlock chapters of cosmic history we've never been able to access. What makes this so powerful is that gravitational waves prove the universe isn't silent. Every cosmic collision sends out a vibration, and with the right instruments, we can listen. They remind us that space isn't static. It's dynamic, alive, and constantly moving. We're not just looking at the universe anymore. we're hearing it sing. So, what are gravitational waves? They're ripples in space-time, born from the most violent events in existence. They've turned the universe into both a stage and a symphony, where black holes, neutron stars, and maybe even the Big Bang itself play their part. Next time you look up at the stars, remember, the cosmos isn't just shining, it's humming, whispering, and sending ripples across space and time. And now, at last, we can listen.